The Internet era in the last 20 years has gone from the Internet of Contents, WWW age, to the Internet of Services, Web 2.0 age, to the Internet of People, social and mobile age, to today, the Internet of Things, or Internet of Everything. Everything from refrigerators to sprinkler systems are wired and interconnected. And while these devices have made life easier, they have also created new attack vectors for hackers. These devices are now collectively called the Internet of Things, IoT. IoT devices are poised to become more pervasive in our lives than mobile phones, and will have access to the most sensitive personal data, such as social security numbers and banking information. Forecasts show an expected IoT universe with between 20 and 30 billion connected devices by 2020. As the number of connected IoT devices constantly increases, security concerns are also exponentially multiplied. A single security breach could give hackers access to massive information in light of the importance of what IoT devices have access to. It is important to understand their security risk. Here is a case study about Wi-Fi camera vulnerabilities. Some manufacturers rarely or never update firmware. It ships with a factory default password that is easy to discover and hack. One of the target device types of Mirai botnet attack of September 2016. Wi-Fi services set identifier, SSID, broadcast continually, making for easy discovery by hackers. Some IP cameras rely on cloud services via non-HTTPS connection. Wi-Fi camera streams non-stop video content, creating network congestions and opportunities for unwanted eavesdropping. The figure here shows a typical IoT ecosystem model, which consists of components such as IoT service ecosystem, for example, IoT solutions, applications, and cloud platform. Communications network, endpoint ecosystems, user experiences are the interaction experience with IoT devices and applications. And lastly, partner APIs. So what is this IoT security pandemic? Millions of devices that have been or will soon be discovered, hacked, modified, or hijacked. Who is affected? Enterprise, industrial, government, consumers. Where? Whole world. How? Poor crypto practices, weak or non-existent firmware update practices. Manufacturers in denial, limited regulatory oversight. Risks are disabled or hijacked world objects like Mirai, modified endpoint data, ransom attacks, spying, homeland security, personal safety. Note, IoT is an ecosystem. IoT security is not just device security. HP, Internet of Things, State of Union Study 2015, reveals 70% of the most commonly used IoT devices contain serious vulnerabilities. This report analyzed IoT devices from manufacturers of TVs, webcams, home thermostats, remote power outlets, sprinkler controllers, hubs for controlling multiple devices, door locks, home alarms, scales, and garage door openers. A majority of devices included some form of cloud services. All devices included mobile applications that can be used to access or control the device remotely. On average, 25 vulnerabilities were found per device, totaling 250 vulnerabilities. Highlights include privacy concern. 90% of devices collected at least one piece of personal information via the device, the cloud, or its mobile application. Insufficient authorization. 8% fail to require passwords of sufficient complexity and length. Lack of transport encryption. 70% devices did not encrypt communications to the internet and local network, and this enables an attacker to identify valid user accounts through account information. Insecure web interface. 6 out of 10 devices that provide user interfaces were vulnerable to a range of issues, such as a persistent XSS and weak credentials. Inadequate software protection. 60% of devices did not use encryption when downloading software upgrades. So what are the takeaways? We have a number of things to take from this report. IoT security is not one-dimensional. We need to look at all the surface areas discussed in this report and in OWASP, Internet of Things, Top 10 projects. We'll discuss this in detail later in order to have a complete view of your risk. IoT security is not just a consumer problem. Corporations need to be looking at how their industrial control system, ICS, and supervisory control and data acquisition, SCADA, systems face when looked at under a similar light. We'll discuss the Ukraine power system attack case later. The current state of Internet of Things security seems to take all the vulnerabilities from existing space, such as network security, application security, mobile security, and Internet-connected devices, and combine them into a new, even more insecure space, which is very challenging to manage effectively and efficiently.